Hello everyone, my name is Mitanshu Garg and today we are starting a video series on all things around Agentic AI. Artificial intelligence is changing. For years, the focus has been on models that excel at passive discrete tasks, answering a question, translating text, or generating an image from a prompt. This paradigm, while powerful, requires constant human direction for every step. We are now seeing a paradigm shift, moving from AI that just predicts or creates content to a new class of software capable of autonomous problem solving and task execution. This new frontier is built around AI agents. In today's video, we are going to learn about the anatomy of an agent. We'll look at the components that make them work and the different levels of agents available today. This foundation will help us in future videos when we actually build agents using platforms like Google Agent Development Kit or Microsoft Copilot Studio. So, what actually is an agent? An agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. Agents are autonomous and can act independently of human intervention, especially when provided with proper goals or objectives they are meant to achieve. Agents can also be proactive in their approach to reaching their goals. Even in the absence of explicit instruction sets from a human, an agent can reason about what it should do next to achieve its ultimate goal. It is important to understand that agent is not just a large language model in a static workflow. Now, in order to understand the inner workings of an agent, let me first introduce the foundational components that drive the agent's behavior, actions, and decision making. An AI agent is a combination of models, tools, an orchestration layer, and a runtime service which uses the LM in a loop to accomplish a goal. These four elements form the essential anatomy of an agent. Just like a human, an agent relies on four main systems working together. Let's dive deeper into each of these four elements, starting with the model or the brain of the agent. The first component is the model, often referred to as the brain. This is the core language model or foundational model that serves as the agent's central reasoning engine to process information, evaluate options, and make decisions. The type of model dictates the agent's cognitive capabilities. Models can be general purpose, multi-model, or fine-tuned based on the needs of your specific agent architecture. You might use a powerful model like Gemini Pro for complex reasoning and a faster, cheaper model like Flash for simple tasks. The goal is to find the right balance of intelligence, speed, and cost. Now, while language models excel at processing information, they lack the ability to directly perceive and influence the real world. This limits their usefulness in situations requiring interaction with external systems or data. This means that, in a sense, a language model is only as good as what it has learned from its vast training data. Imagine a world class chef located in an empty room. They know every recipe by heart. They can tell you exactly how to cook a perfect dinner. But without a kitchen, an oven, or ingredients, aka the tools, they cannot make you dinner. They can only describe dinner. As a different analogy, you can think of a model like a YouTube tutorial on how to fix a flat tire. It gives you perfect instructions, but an agent is the mechanic who actually comes out and changes the tire for you. Next, we have the tools or the hands of the agent. The brain needs hands to affect the real world. Without them, a model is confined to its training data. Tools connect the agent's reasoning to the outside world. This includes API connectors to talk to software like Jira, CRMs, or email, data retrieval tool to search the live web or query your internal databases via RAG, and even code execution environments where the agent can write and run code to solve math problems or analyze data. Important thing to understand here is that tools bridge the gap between the agent's internal capabilities and the external world, unlocking a broad range of possibilities. Connecting the brain and hands is the orchestration layer, which acts as the nervous system. It governs how the agent takes in information, performs some internal reasoning, and uses that reasoning to inform its next action or decision. It handles planning, memory, and reasoning strategy execution. In general, this operation loop of orchestration layer will continue until the agent has reached its goal or a stopping point. The complexity of the orchestration layer can vary greatly depending on the agent and task it is performing. Think of the orchestration layer like a general contractor building a house or remodeling a kitchen. As a user, you would say, just build me a kitchen. The contractor will break that down. First, I need a plumber, then I need an electrician, then a painter. It doesn't try to do everything at once or on its own. It calls the right expert, the tool, the agent, at the right time. Now, finally, we have the body or the deployment infrastructure. An agent is software and it needs a place to live. This includes hosting the agent as a scalable service and a production environment, setting up monitoring to log its thoughts and errors, and capturing the user feedback, and implementing guardrails to ensure it acts safely and doesn't perform unauthorized actions. Now, before we move on to different type of agents, I want you to change how you think about a role. When building agents, you are no longer just a typical software developer or a bricklayer who writes the code line by line. You are a director. Your job is to set the scene by crafting guiding instructions and prompts. You select the cast by choosing the right tools and models for the job. And you provide context by supplying the domain expertise and data the agent needs. The primary task becomes guiding this autonomous actor to deliver the intended performance or meeting our ultimate goal. You'll also find that since language models are non-deterministic in nature, so their incredible flexibility also require careful prompt engineering and context engineering to get the output we need. For any single call to the language model, we input our instructions, facts, available tools to call, examples, session history, user profile, etc., filling the context window with just the right amount of information to get the output we need. As a director for the agents, you must watch the thought process of the agent and monitor its performance. You're no longer the player on the field kicking the ball. You are the coach on the sidelines. You train the players, which are the agents, you give them the playbook, the prompts, and you put them in the best position to win. But once the whistle blows, they play the game. As an agent director, you'll have to make architectural decision to determine the agent's degree of autonomy. Do you need language model as a tool for specific task alone, or do you need it to be in the driver's seat? A parallel choice will be to select the implementation method. Do you use a no-code builders or code-first frameworks? Remember, when an agent is precisely configured with clear instructions, reliable and relevant tools, and an integrated context serving as a memory, a great user interface, the ability to plan and solve problems, and general world knowledge, it transcends the notion of mere workflow automation. It begins to function as a collaborative entity, a highly efficient, uniquely adaptable, and remarkably new member of your team. Now that we understand the anatomy and role of the agent director, let's look at different types or classes of agentic AI systems. Not all agents are created equal, and we can classify them from a hierarchy of 5 levels, ranging from simple reasoning engines to fully autonomous self-evolving agents. As an architect or product leader or agent director, a key initial decision will be to scope what kind of agents to build. Let's dive deeper into each of these 5 classes. We start at level 0, the core reasoning system. This is the brain in isolation. Think of a standard ChatGPT session with no plugins. It operates solely on its vast pre trained knowledge without any tools, memory, or interaction with the live environment. Its strength lies in this extensive training, allowing it to explain established concepts, but with a trade off in lack of real time awareness. It works blindly to any event or fact outside its training data. Think of a level 0 model like a printed set of encyclopedia from 2022. It contains the sum of human knowledge up to that date. It can explain complex quantum physics or the history of Rome in perfect detail. But if you ask it, what is the weather like in London right now? It is useless. It is frozen in time. An isolated model is like a printed roadmap. It knows every street, highway, and landmark perfectly, but it cannot tell you where the traffic jams are right now. It can explain the rules of baseball, but it can't tell you who won the game last night because it has no connection to the real world. Moving up the ladder, we arrive at level 1, the connected problem solver. Here the agent gains hands. It becomes a tool user. It is no longer confined to its static pre trained knowledge. If you ask what was the final score of the Yankees game last night, a level 1 agent recognizes it doesn't know the answer, calls a Google search tool, observes the result, and gives you the score. Whether it's checking stock prices or querying a database via RAG, this connection to the real world is the defining feature of level 1. Now, coming up to level 2, it marks a significant expansion in capability. The agent moves from simply executing tasks to strategic planning. It acts as a planner. It starts to think before it acts, using techniques such as chain of thought or react, reason, and act. The key skill here is context engineering. The agent actively selects and manages relevant information to solve multi step problems. If you ask it to plan a trip to Tokyo, it doesn't just search blindly, it breaks the problem down into smaller steps like flights, hotel, etc. At level 3, we see collaborative multi agent systems. This is where it gets exciting. We move away from building a single all powerful super agent and we move towards a team of specialists, mirroring a human organization. Imagine a project manager agent. It receives a mission to launch a new product. It doesn't do all the work itself. Instead, it delegates. It tells a research agent to analyze competitors, a marketing agent to draft a press release, a coding agent to build the landing page. These agents treat other agents as tools, collaborating to achieve a complex workflow. And finally, we reach level 4, the self evolving system. This is the future frontier. Level 4 represents a leap from delegation to autonomous creation. At this level, an agent can identify gaps in its own capabilities. If a level 4 agent realizes it needs to track social media sentiment but doesn't have the right tool, it doesn't fail. It effectively thinks, I need a new tool. It can autonomously create the code and create a new sentiment analysis agent, a tool on the fly to solve the problem. It turns a static team into a learning, evolving organization. As we build these systems, we must remember that agents' responses are probabilistic by design. So traditional software testing won't work. This requires agent ops, a disciplined approach to managing the unpredictability of AI. Approach of agent ops turns unpredictability from a liability into a managed, measurable, and reliable feature. When evaluating your agent performance, we must cherish human feedback. Every time they hit a thumbs down, that is a very valuable source of data for improving your agent. It gives you a real world edge case. So it would help you to vaccinate your evaluation system using the feedback. To wrap up, understanding the agent anatomy, starting with the model, the tools, the orchestration layer, and the deployment system, and also understanding the 5 levels of complexity is critical. It will help in scoping the ambition when developing an agentic AI system. The success of the agentic AI system will not come from just a prompt, but it will come from the engineering rigor we apply to the entire system. Robust tools, sophisticated orchestration, and comprehensive evaluation. If you found this video useful, please like and subscribe, and in the next video, we'll continue with live building of an agent. Thank you for watching.